In this video, let us learn to calculate the Young's modulus of the material of the wooden bar which is used as a cantilever, and also to verify the obtained results graphically by drawing a load shift graph. This set of experimental readings obtained corresponds to the length of the cantilever L equal to 40 centimeters, and in the table we could see the first column load. The first load is dead weight W and it is increased in steps of 50. So, we have W plus 50, W plus 100 till W plus 350. In the next column we have a scale readings or telescope readings for loading and unloading. See, for the first weight dead weight W, the scale reading for loading and unloading is 40.5 and 40.4, and the next scale reading for loading and unloading for the weight W plus 350 is 41.3 and 41.1. So, all throughout this different weights we could see the scale readings for loading and unloading are almost same, which means we can take the mean of these two readings. This also ensures the correctness of the readings taken. So, for the first dead load W, for loading and unloading we have 40.5 and 40.4 and the mean is 40.45, and for W plus 50 the loading we have 41.3, for unloading we have 41.1, so the mean is 41.2. In the same way we can take the mean of the scale readings corresponding to unloading and loading till W plus 350. For the last reading it is 45.6 and 45.6, so the mean is 45.6. So, the next step is to find the shift. We can find the shift for any mass, like for 50 grams or for 100 grams, for 150 grams. Here the shift is found for 200 grams. So, for finding the shift for 200 grams, we have to subtract the dead load with every 200, for every 200 gram difference we have to find the shift. See, the first reading which is highlighted in red color and the fifth reading it is also highlighted in red color. So, the first reading is W and the fifth reading is W plus 200. So, finding the difference of these two scale reading will give the shift for 200 grams. So, 43.4 minus 40.45 gives us 2.95. The next 200 gram shift difference is between W plus 250 minus W plus 50, which is highlighted in green color. The corresponding scale readings are 44.05 minus 41.2. So, you will get 2.85. The next is W plus 300 minus W plus 100, which is highlighted in blue color. The corresponding scale reading is 44.85 minus 42, you get it as 2.85. The last 200 gram difference is between W plus 350 minus W plus 150, which is highlighted in black color, and the corresponding scale reading is 45.6 minus 42.75. So, we get the shift as 2.85. So, we have 4 different shift values. Each shift values are almost same. The 4 shift values are almost same. So, we can take the average of these 4 readings. So, adding this 4 readings 2.95 plus 2.85 plus 2.85 plus 2.85 gives 11.5. Then divided by 4 you will get the mean shift S as 2.875 centimeters or 2.875 into 10 power minus 2 meters. So, this shift corresponds to the length of the cantilever L equal to 40 centimeters. We can repeat the experiment for different length of the cantilever. It is ideal to choose the length of the cantilever between 35 centimeters to 45 centimeters. If you go beyond 50, at 50 we know the scale is at a neutral point where you cannot find bending. When you go beyond 50, the scale bends more. So, the ideal length is between 35 to 45 centimeters. You can repeat the experiment for for the length of the cantilever to be at 35 centimeters, and check your results with length of the cantilever at 40 centimeters. So this table corresponds to the breadth of the bar, which is to be which is found using vernier caliper, and here the breadth of the bar be equal to 2.868 centimeters or 2.868 into 10 power minus 2 meters. The next table represents the thickness of the bar D, which was found using screw gauge, and the breadth of the the thickness of the bar D equal to 5.818 into 10 power minus 3 meters. So now let us know, we have already mentioned the distance between the clamped end and the position where the weight hanger was suspended, that is the length of the cantilever is 40 centimeters, and the distance between the mirror and the scale here, that is the capital D, is 53.5 centimeters or 53.5 into 10 power minus 2 meters. Now let us calculate the Young's modulus Q. The mass for which the shift found is 200 grams or 200 into 10 power minus 3 kilogram. When we write it in SI units, G we know 9.8 meter per second square. L, the length of the cantilever 40 centimeters, 40 into 10 power minus 2 meters. Capital D, 53.5 into 10 power minus 2 meter. The breadth B, 2.868 into 10 power minus 2 meter. D, 5.818 into 10 power minus 3 meter. Shift S, 2.875 into 10 power minus 2 meter. I would advise all the students to write all these number over the head of the formula, and I advise you to write all the parameters in terms of SI units. So when you write everything in SI units, you need powers. So to convert the gram into 1 kilogram, you need 10 power minus 3 power there. So when you write everything in SI units, your calculation will be fine. So the formula to calculate Q, that the Young's modulus Q is equal to 12 mg L square D divided by BD cube S Newton per meter square. Let us substitute the values. 12 into 200 into 10 power minus 3 into 9.8 into 1040 into 10 power minus 2 the whole square into 53.5 into 10 power minus 2, everything divided by 2.868 into 10 power minus 2 into 5.818 into 10 power minus 3 the whole cube into 2.875 into 10 power minus 2. So in the next step, let us separate all the powers and the numbers. So separating all the powers and numbers, we get 12 into 200 into 9.8 into 40 square into 53.5. So this 10 power minus 3 comes from M into 10 power minus 4 comes from the length. Squaring the length, we get 10 power minus 4, and from D we have 10 power minus 2. In the denominator we have 2.868 into 5.818 the whole cube into 2.875. From the breadth we got 10 power minus 2. From the thickness D cube we get 10 power minus 3 the whole cube, 10 power minus 9 into 10 power minus 2 from the shift. And the next step, what we do, we multiply all the numbers and add all the powers. So when you multiply, we get in the numerator 201331200 into 10 power minus 9. See, in the numerator you see you have a minus 3, minus 4, minus 2. So totally we have 10 power minus 9. This is divided by the denominator. So when you multiply all the denominators, we get 1623.820, and add up the powers in the denominator, minus 2, minus 9, minus 2. So the totally they add up to 10 power minus 3. So in the next step, you divide the numerator and the denominator. We get, when you divide, you get 1239861.561, and the powers in the denominator is taken to the numerator. So we get 10 power 9 is 9 plus 13, which will give 10 power 4. So and you push the powers inside, you will get one, you take the powers outside, sorry. So when you take the powers outside, 1 2 3 4 5 6, so I have moved the 6 decimal points, so and I have wrote it as 1.2398. Since I have moved the 6 decimal points, so I got 10 power 6, and 10 power from already the power already existing. So this 10 power 6 plus 10 power 4 adds up to give 10 power 10. So we have got Q is equal to 1.2398 into 10 power 10 Newton per meter square. This is the Young's modulus of the material of the wooden bar used. So for the all the elastic moduli, we get the powers as 10 power 10. So students find it's very difficult to get the power of 10 power 10 correct. So if you calculate by this way, definitely you will get the power and the results like this. Okay, so we have calculated the Young's modulus by calculation method, and let us verify this by drawing the load shift graph. For drawing the load shift graph, we need the shift readings. So see, from the first table I have taken the load readings and the mean values of the scale readings. For W it is 40.5, and for W plus 50 the mean is 41.2, and for W plus 350 the corresponding mean value is 45.6. See, what I have done here is I have highlighted the dead load W in red color. See, look at the next table where we have the load as 50, 100, 150, 350 till 350, and we need to find out the corresponding shift for each load. For this, what we have to do is you have to subtract the dead load with every consecutive load. That is, first subtract W plus 50 minus W, that is 41.2 minus 40.5, you will get the shift for 50 grams as 0.75. Then W plus 100 minus W, that is 42 minus 40.5, you will get the shift as 1.55. Okay, you subtract the dead load with every load readings, you will get the shift for 50, 100, 150, 200 till 350. For 350, for finding the shift for 350, what we have to do is we have to do W plus 350 minus the dead load W, which is highlighted in red color. So we get 45.6 minus 40.5 as 5.15. So we have the mass or the load and the corresponding shift for all these loads. Now let us draw graph for this reading. For this, let us take a graph sheet like this and separate this graph sheet into two. In the x-axis, take mass, which is 10 power minus 3 kilogram, and in the shift side, take y along the shift along the y-axis, which is in centimeters, that is in 10 power minus 2 meters. Whenever we draw a graph, it is mandatory to write their units with the powers. So looking at our mass and shift, we have to choose an appropriate scale. So on the x-axis, we have 1 centimeter equal to 50 grams, that is 50 into 10 power minus 3 kilogram. On the y-axis, we have 1 centimeter equal to 0.5 centimeters, that is 0.5 into 10 power minus 2 meters. Next, plot these values. So we have plotted along the x-axis as 50, 100, 150, 200, 250 till 350. And on the y-axis, we have 0.5, 1, 1.5, 2. It goes on till 6, I think. Okay. Next, with this load shift values, let us plot the graph. When you plot, you will get a points like this. So for 50 it is 0.75, for 100 it is 1.55. so plot using these values, we will get a graph like this. By looking at the position of the point itself, we could see it will come like a straight line. Then join the graph. You could see, actually you have to, okay, join the graph. One or two points may not fall on the straight line, let's not bother about it. So the join the maximum points which fall on a straight line, okay, then draw a slope like this. So from this slope, okay, from this slope let us find out the m by s. So we all know the slope is equal to dy by dx. So along the y-axis we have the shifting s, along the x-axis we have m, that is your dx. So the corresponding intercepts along the y-axis is found to be 2.05 into 10 power minus 2. In the same way, along the x-axis it is found as 140 into 10 power minus 3 meters. So taking the inverse of this, we get m by s, that is 140 into 10 power minus 3 divided by 2.05 into 10 power minus 2. When you divide this m by s, we get it as 6.825 into 10 power minus 3. The new power in the denominator, when it goes up, you get 10 power 2. So m by s is 68.29 into 10 power minus 1. Let us pull the power in, push the power inside, so you get 6.829. So we got m by s as 6.829. Now let us do the graphical calculation. So from the experimental, we have a experimental reading, we have g as 9.8 meter per second square, L 40 centimeters, D 53.5 into 10 power minus 2 meter, breadth as 2.868 into 10 power minus 2 meter, D we know 5.818 millimeter. The shift from the graph is 6.829. So we know the formula Q is equal to 12 mg L square D by BD cube S, where the m by s has been taken outside and written separately, and substituting all these values, we get 12 into 9.8 into 40 into 10 power minus 2 the whole square into 53.5 into 10 power minus 2 into 6.829 divided by 2.868 into 10 power minus 2 into 5.818 into 10 power minus 3 the whole cube. Then separate the numbers and separate the powers. Then you multiply all the numbers and add up the powers, we get 68744,538.24 into 10 power minus 6 the whole thing divided by 56481 into 10 power minus 11. Then take the powers, then divide the numerator and the denominator, you will get 121,712.679, and take the powers in the denominator to the numerator, you will get 10 power minus 6 plus 11. So you will get 121,712.679 into 10 power 5, and pull the powers outside, you will get 1.217 into 10 power 5. Again from the powers in the previous step, you will have another 10 power 5. So you will get 1.217 into 10 power 10. So we have got the value of Young's modulus of the material of the wooden bar as 1.217 into 10 power 10 Newton per meter square. So which is in line or in accordance with the values obtained theoretically or by the calculation method. So in calculation method, we have got 1.23 into 10 power minus 10. Graphically we got it as 1.21 into 10 power 10 Newton meter square. Hence we have verified the Young's modulus of the material of the bar both by calculation method as well as by graphical method.